All right, ladies and gentlemen, I'm making this video as a little kind of review or mini tutorial about what we did in class today. So I'm using problem D from your notes. I'll start with the perimeter. Remember, perimeter is the distance around a figure, so it can't be anything inside the figure. Now, I will point out to you that these arrows are not a part of your figure. They are just indicating that from here to here is 4 centimeters and from here to here is 6 centimeters. So the perimeter of your figure is actually these pieces right here. Okay, so those pieces consist of 3 edges and 2 semicircle circumferences. So when I'm writing out my expression or equation, I would say 11 plus this side right here is 10 centimeters because over here it added up to 10. So 11 plus 10 plus another 11 down here plus, we discussed in class today that half of a circumference, the equation is pi r. So the radius here would be 3 centimeters and the radius here would be 2 centimeters. So pi r here would be 3 pi plus pi r here would be 2 pi. And now I have them all checked off so they're all included in my perimeter. Now, we cannot add together terms that don't have pi and terms that have pi. They have to be kept separately. So none of these terms right here have pi, so we can put them together, and I think that makes 32. And these terms right here make 5 pi. So 32 plus 5 pi, and that's as simplified as you can get. So you just put centimeters on your answer. Now on your homework tonight, it asks you to not only put your answer in terms of pi, but also to put it to the nearest tenths place. So I'm going to model that with this problem. Since you have your answer in terms of pi, I would always recommend doing your answer in terms of pi first, because then it makes it really easy. You would just say perimeter equals 32 plus 5, and then substitute in 3.14 for pi. Now, when you do 5 times 3.14, I think that gives you 15.7 plus 32. Okay, and then 32 plus 15.7 makes 47.7 centimeters. So your perimeter in terms of pi is right here, and to the nearest tenth would be right here. All right, now let's talk area. I'm going to go ahead and erase everything. Area on this problem consists of a rectangle, because we said this side was 10 centimeters. So it's a rectangle, but these 2 semicircles have been removed. So area of a rectangle would be base times height. Area of each semicircle would be pi r squared divided by 2 here, and pi r squared divided by 2 here. I have to do them separately because they're not the same size semicircle. So area equals base times height minus. Now what I'd probably do is I'd probably calculate the 2 half circle areas, add them together, and then subtract that from the area of the rectangle. So to show that, I need to include some parentheses and say pi r squared divided by 2 plus pi r squared divided by 2, because order of operations applies here. Okay, now the base of my rectangle is 11 and the height is 10. The radius of the top circle was 2 and the radius of the bottom circle is 3. All right, 11 times 10 is 110. 2 squared is 4, so 4 pi over 2, plus 3 squared is 9, 9 pi over 2. And 4 pi divided by 2 is 2 pi, plus 9 pi divided by 2 is, let me erase that, 4.5 pi. So the area of the smaller semicircle is 2 pi. The area of the bigger semicircle is 4.5 pi. I need to take both of those areas away from 110. So that's why I'm going to add those two together and get 6.5 pi. And then I would subtract that total from the area of the rectangle. Now this term has pi and this term has pi, this term doesn't. So I'm done. I can't combine them. Put your units on it, centimeters squared. And that's it. Now, to the nearest tenth, obviously you would plug in 3.14 for pi and solve from there and get your answer as a decimal. All right, I do want to show one more example that you'll see on your homework tonight, just to kind of clarify, and it involves a circle, kind of. But let me fix it. This circle, oops, it's two semicircles that have been put together, but they're not the same size. So we'll say that's one of them. Close that up. And the other one we'll say is a little bit smaller. I think this is like number 6 on your homework. Alright, so we'll do this. Group that. Oopsie. Undo. Here, let me just move it over here. Okay. Now, people usually miss this problem because they're not highlighting as they are calculating the perimeter. Area shouldn't be a big deal. You should be able to get the area of this figure, no problem. Find the area of one semicircle, add it to the area of the other. But let's say that the distance from here to here, let me use another color, let's say that's 8. So it's the diameter of the smaller semicircle, but it's the radius of the bigger. So we're just going to focus on the perimeter of this figure. So the perimeter, let's start with this part. That's half of a semicircle, or that's half of a circle, a semicircle, so it would be pi r. Then we would add to that the circumference of this semicircle, which the radius of this circle would be 4. So that would be another pi r. But here's what people miss. They miss this edge right here. That is another radius of the bigger semicircle, which is 8. So you have to include that in your perimeter. Now we have the whole perimeter highlighted, so we know we've included every edge. So pi r, your first radius was 8. Your second radius was 4 plus the 8 edge. So that's 8 pi plus 4 pi plus 8, or 12 pi plus 8 in its units. And then for area, obviously you would just do pi r squared divided by 2 plus pi r squared divided by 2. Nothing fancy going on there. Okay, I hope this helps. Don't forget you have a quiz tomorrow. Make sure all of your notes are glued into your spiral so that you can use them. And check your homework on Edmodo.